So today we're going to discuss how to make the most and least stable Newman projection of this molecule, 3-ethyl-2,4,4-trimethylheptane. So looking down from the third bond to the fourth bond, we're seeing the third bond at the front with an ethyl group reaching off of it, an isopropyl leading at the bottom, and then the other fourth carbon behind it. So to draw a Newman projection of that, we're going to look at the carbon in the back first. So this is going to have a methyl group coming from each side. So those will be actually switched around. So these are on the top instead. So we'll have the we'll have the two methyl groups coming from the left and the right based on the dash and the wedge, which really doesn't matter because they're the same atom group. And then at the bottom is this large group coming through. So this is the 3 carbon group coming off of the end. And in the front, you're going to have the isopropyl group. Remember, this is switched, so this is actually at the top, with the ethyl group coming off of the top. And then you're going to have a separate hydrogen that is not seen. Now, in order to make sure that you have the most stable connection, you want to make sure that this isopropyl, which is the largest group on the front carbon, is as far away from the largest group on the back carbon. So in order to do that, you want to have them in an anti-conformation, so just generally facing away from each other. And then with the others, you'll just place them in a different place because there's no other placement for them. For the least stable, you want to have those two interacting because they're the largest, and so they're going to have the most unstable interaction. And they're going to be in the eclipse formation. So that's how to draw your Newman projections, is to ensure that with the least stable, the two larger groups are not interacting or are the furthest apart as possible. And with the most stable, or with the least stable, the two largest groups are interacting with each other.